Okay, so on this problem, we are looking at, this is from section 6.7. Write this down. Section 6.7. Okay. The fox population in a certain region has a continuous growth rate, and that's an important word. We'll come back to it. Continuous growth rate of 6% per year. It is estimated that the population in the year 2000 was 24,500. Find a function that models the population t years after 2000. Hint, use an exponential function with base e. Here's your answer. And then use that to estimate 2008. Okay. How does this work? Well, if you go to the notes, so here we are. Here's the exam 4 notes. So the exam 4 notes. We have a some stuff that we need. And so it's continuous or exponential growth or decay. So remember, we've had different kinds of we've had doubling and halving, but now this is continuous or exponential growth or decay. What do you do? Well, the continuous growth or decay formula is this right here. And R is the rate of growth. So that's we use the PERT formula, just like we did for continuously compounded interest for money. It's the same thing for, biological continuous or exponential growth. You use the PERT formula. Okay. So let me write that. So for part A equals PERT. And so, and then the rate, it said the rate of growth, at least on mine, is 6%. So that's 0.06, change to a decimal. And P, remember what P always is? It's the starting amount. So that'll, well, I should do it the other hand. The P will end up being the, in my case, 24,500. P is always the starting amount. Like the print in an investment account, it's the starting principal. Money, it's the starting amount. E to the RT, and the R is 0.06, and T is the time. So there's our function. I call it A, they call it P of T, whatever. There's the formula. So 24,500 E to the 0.06 T. So there's the PERT formula. Put in the P as 24,500 or whatever starting amount they gave you. And the R, the rate of continuous growth, is 0.06, just like an interest rate of 6%. So it's just like the interest rate formula for continuously compounded interest. Now in part B, they want us to use this formula, 24,500 E to the 0.06 T, and we're going to plug in. It says in the year 2008. Well, remember, T is 0 in the year 2000. So T is 8, because T is how many years after 2000. So that means T is 8 years after 2000 in the year 2008. So let's plug in 8. So I'm going to grab that 8, plug it in right there for T. So we will get, what will we get? 24,500 E to the 0.06 times 8. So hit the buttons on your calculator for that. I'll hit the buttons on my calculator. You can figure out the power first if you want. Right, if you want to figure out the power, if you multiply these, it's 0.48. You can just do that. The amount I get is 39,593, 0.822. It says an integer, so it knows you can't have part of a fox. We're doing the fox population, so it'd be 594 rounded to a whole number of foxes. Right, this formula is just estimating. It's an estimate. It's not exact, but it'd be about 39,594 foxes. Is that the plural for fox? I don't know. Foxes, yeah. In as the population for the year 2008. So if the population continues to grow at 6% per year, and it started out at 24,500 in the year 2000, only 8 years later it would be almost to 40,000. 39.5. See how fast exponential growth is? That's just growing 6% per year. But it goes up 6% and then goes up 6% on the increase, and it just keeps going like that. So that's a big growth. So there we go.